So here's a worksheet that I want you guys to do today, and we're going to do some more problems of this tomorrow. Today I want you to focus in on 2, 3, 5, 16, and 19. I just rewrote number 19 right there, and I also have the notes that we have from yesterday. I want you to get comfortable with those notes, but I do want you to recognize that these notes, the whole purpose of the notes is to end up with a 2x2 system that you could solve with linear combinations method, okay? And I believe this one's a special case problem. It does say step 1, use 2 of the 3 original and get a variable to cancel. So before you begin, look at all of your x's, look at your y's, look at your z's. Which variable do you think would be easier to deal with?
Y.
X's, y's, or z's?
Y.
Y.
And the last two.
You know what? I think z's would be easy because you have a 1z right here, right? Which you could easily change to a positive 6, which will cancel with the negative 6. And you could easily change this to a positive 4, which will cancel with the negative 4, right? Yeah, you guys are right. It's also equally easy to cancel out y's, but easier to cancel out y's because you got a negative 3y and a positive 3y. So anyway, which one do you guys want to cancel? Y's? And which 2 equations do we want to start with? The middle and bottom. Okay, we're going to use this middle one, this bottom one. I highlighted them in yellow because that's highlighted in yellow up here. We picked 2, and we're going to get a variable to cancel, which would be the y's. So you could rewrite both of these over here on the side, or if you wanted to, since you're not modifying anything, you could just combine them and cancel those guys right there. That's kind of lazy of me. Should I rewrite them?
Yeah.
Yeah, I should. Okay, so let me rewrite them. We got 3x minus 3y minus 6z equals negative 3. We have negative 2x plus 3y plus z equals 7. We are combining them. That cancels. We have x minus 5z equals 4. And this is what we call new equation number 1. And then we go back. We go to step 2. It says go back to the original. Use the one you have not used yet. This is the one we have not used yet. Right? It's highlighted up here in red. I'm highlighting it in red. But this is equally important. Get the same variable to cancel. So you need the y's to cancel. So you need to use this one, and you need to make this negative 2y disappear. So obviously, we have a negative 2 here and a positive 3 there. We can't just combine them. We're going to have to modify both equations. So I am going to rewrite my top one. I'm going to put an arrow, and as I'm putting my arrow, I'm going to put multiply. These are notes to myself. Multiply by 3. Now, why would I do that? Because when I multiply by 3, I will get 6x minus 6y minus 12z equals negative 6. Are you with me? Okay, and why did I do that? Because now I could go to my bottom one, this guy right here, and I want to draw an arrow going this way, and I want to put multiply by what?
2.
By 2, okay? And when I multiply by 2, that bottom one, I will get negative 4x. I'll get positive 6y plus 2z equals 14. And of course now, we could combine those. The y's cancel, same variable cancels. We end up with 2x minus 10z equals 8. And this is our new equation number 2. Well, maybe I was wrong. Maybe this is a regular problem. It's not a special case problem. New equation number 2. Okay. And our whole purpose of doing that was to get to step 3, which is creating a new 2x2 system that we could all solve using linear combinations method, also known as elimination method. So for step 3, I want to take this one and put them together to create my new 2x2 system, the new 2x2 system. So how am I going to do that? I'm simply going to put both of those blue equations together. I have the x minus 5z equals 4. I have 2x minus 10z equals 8. Now I could focus in just on solving the new 2x2 system. After all, step 3 says create and then solve it. So we need to solve this guy, okay? Let's zoom in and just focus in on that new 2x2 system. What do you think? Do you want x's to cancel or z's? X's? Okay, so let's multiply that top equation by? If I just go 2, negative 2, there you go. So when we multiply by negative 2, that'll give us a negative 2x, a positive 10z equaling negative 8. And, okay, I guess I was right originally. Everything cancels out. So this does become a special problem. 2x, just rewrite it, minus 10z equals 8. And yes, that cancels, this cancels, that cancels. That means that you have nothing equals nothing, which is always true. It's always true. So that means infinitely many solutions. Infinitely many solutions. Okay? So that was a special case problem. And yeah, you just stop right there. Oh, it's longer because sometimes it won't cancel out like that, and you got to get those answers and then plug them back even further to find your third answer. So there's a lot of steps to this. There's so many steps, and you could be doing it a different way than your partner. But yeah, let's go back to the worksheet here. Now, what I want you to understand is that these notes that we got yesterday, the whole purpose of these notes is to create a 2x2 system that we could solve. Okay? So sometimes we're going to have to just recognize that we want a 2x2 system, and we could just throw these steps to the side. For example, number 3, a lot of people freak out with number 3. It is on our worksheet. Why are we freaking out? Because we're like, well, isn't this supposed to be a 3x3 where we have 3 equations with 3 variables each, right? And it throws us off because we don't see those 3 variables in each equation. So you could just start messing with this, right? You could like solve for b and get the a over there, and then you could substitute that binomial into the other b value. You could start messing with it, right? Or if you kind of want to make it look a little more visually comfortable, you could leave spaces for those missing variables that you're used to. For example, number 1, or the first equation, you could write it as a plus b plus blank spot, because there is no c, equals 3. And then the second one, you could say negative b plus c equals 3, but notice that I left a blank spot for a because it didn't have the a. This one doesn't have the b, so you could write it like this: a blank spot plus 2c equals 10. And that might help you a little with these blank spots there, right? Now, if we take a look at this, let's just play with this here. Let's forget about the steps, like, oh, pick 2. Like, let's forget about that. Remember, the goal is to get a 2x2 system. So could you guys tell me what we could do to get something to cancel? Cancel b's, right? Just by combining the first one and the second one. So let's do that. Let's rewrite the top one. A plus b equals 3. Rewrite the middle one. That's a negative b plus c equals 3. And when we combine them, the b's cancel, the a comes down, the c comes down, and the 6 comes down. Now I know what you're thinking, like, what the heck, what's the point of that? I still have a 2-variable equation, but that's okay. Because when we look at our equation, our system again, right here, we could call this new equation 1 that has a's and c's, and look at the one we haven't used. We've used the top one, the middle one, we have not used this one, and it's also an equation with a's and c's. Does that make sense? Yeah. So I could use this one that we just created and this one and put it together as a 2x2 system, and then I could solve it. Okay? It's not really skipping, well, yeah, it's like skipping steps, but it's more like the whole purpose of those steps was to get a 2x2 system, because we could solve 2x2 systems with linear combinations. So we combined some lines and we ended up with an equation that has 2 variables. And over here we happen to have a different equation, the one we haven't used yet, and it has the same 2 variables. So I could just put those together and have a new 2 by 2 system. So I'm going to write this one right here. A plus 2C equals 10. And I'm going to write this blue one right there. A plus C equals 6. And here's my new 2 by 2 system. So how could I solve this 2 by 2 system?
Multiply by 2.
You can multiply by -2, the bottom one, or you could simply multiply by -1 and cancel out the A's. It's totally up to you. What do you guys want? -1. Okay, let's go with -1 right here. So the top one's going to stay the same. Top one's going to stay A plus 2C equals 10. Bottom one's going to become -A minus C equals -6. And the A's cancel. 2 take away 1 is 1C equals 4. We have one answer. We're solving the 2 by 2 system. Plug in the C value of 4 into, I would go with the bottom equation, A plus, take that 4, put it right there in place of C, equals 6. Subtract 4, A equals 2. So we have the A value, we have the C value. How could we get the B value? By plugging them in, right? So we want the B value. So we could plug in the A value of 2 into the top one.
The middle one, and just do the B.
Or we could do the middle one and just plug in C so we could solve for B. It's totally up to you. Okay? It would be pointless to plug it into the bottom one because the bottom one doesn't even have that third variable that we need, which is B. So which one do you guys want to do? The top one or the middle? Top one says A plus B equals 3. A plus B equals 3. Now I put a parenthesis there because A is 2. So I put a 2 right there. So I really have 2 plus B equals 3. Subtract 2. We now know that B equals 1. So we have our ordered triple answer, 2, 1, 4. So this one was different because we didn't have the usual 3 equations with 3 variables. But as you could see, when I rewrote this guy, but with blank spots, A plus B with a space, and then space for A, and then minus B, and then plus C right there equals 3. When we write them with blank spots, we could line them up, and it'll be easier to see what we could combine to eliminate something. And we did eliminate B's, got an equation with just A's and C's, and we saw that the other one had just A's and C's. So we created our new 2 by 2 system that we solved, and then plugged back in to find the third answer. So the steps are great when you have your traditional 3 equations with 3 variables, but sometimes you got to just push the steps to the side and think, what is the purpose of those steps? It's to get a new 2 by 2 system. So whenever you could get 2 equations that have the same 2 variables, that's the purpose of it, to be able to create a 2 by 2 system to solve. These are also interesting because not all 3 equations have 3 variables. Should we do another, or you guys just want to have time on your own? So number 2, a lot of people are messing up on it or have questions about it. So I'm going to take number 2 and I'm going to explain it over here on the side. Give me a second. So we know that they're giving us an answer right here. Indirectly, they're telling us that z equals -4, right? If you take that third equation, divide by 4, we get z equals -4. That is an answer. Now, remember, those steps that we've been practicing with, the whole purpose of those steps is to create a 2 by 2 system that we could actually solve, right? Okay, so if I take the z value of -4 and put that -4 right there and also right there, I'm going to get 2 different equations without any z's. So the top equation will be x minus 4y plus 3z, which is times negative 4, equals negative 27. And then, of course, you want to clean it up. You don't just want to leave it like that. What do I mean by clean it up? Well, what is 3 times negative 4? That's negative 12. So you really have x minus 4y minus 12 equals negative 27. You don't want that minus 12 there. So you could add 12, add 12. We're cleaning it up. We're getting the x and the y by itself on the left side. We end up with x minus 4y equals negative 15, right? And you could call this your new equation 1 that has two variables. And we got this new equation by taking the negative 4, plugging it in up here, rewriting it, and making it look nicer. We're going to do the same for the middle equation. We're taking the z value of negative 4, we're plugging it in right here, and we're going to end up with 2x plus 2y. Again, I'm just rewriting it, 2x plus 2y. But instead of minus 3z, I want to put minus 3 times z equals 22. And I am plugging in the negative 4 right in there. Does that make sense? Yeah. Now this equation's ugly. I need to make it look nicer. I need to clean it up. What do I mean by that? Negative 3 times negative 4, that's positive 12. Bring down the 2x plus the 2y. Bring down the equal sign of the 22. Now let's get the x and the y by itself. We're going to subtract 12. Subtract 12. We now have 2x plus 2y equals 10. And now we have a two-variable equation. You could call this one up here new equation 1 if you want to. New equation 2. And again, the beauty is that we have both x's and y's and x's and y's. Now we could actually put both of these two-variable equations together to write a new 2x2 system. So here's my new 2x2 system right below that. It'll be x minus y, or minus 4y, equals negative 15. And we have 2x plus 2y equals 10. So we could focus in on that. What do we want to cancel, x's or y's? Multiplying the top one by negative 2 will cancel out x's, right? I'm running out of space here. So I want to take that negative 2 times x, get negative 2x. Negative 2 times negative 4, positive 8 with the y. Negative 2 times negative 15 is positive 30. The bottom one, I'm just going to rewrite it. 2x plus 2y equals 10. Combine the lines, eliminate those x's. 10y equals 40. Divide both sides by 10. Y equals 4. We have the y value of our 2x2 system that we created. Let's plug it back in. I want to plug it into the top equation. The top equation of the 2x2 reads x minus 4y equals negative 15. Of course, I'm plugging in that 4 right there, the y value of 4. So I really have x minus 16 equals negative 15. Simply add 16 to both sides, giving you x equals 1. So we have the x value of 1, the y value of 4, and originally we had the z value really easy by dividing by 4 on both sides. So our ordered triple is x value of 1, y value of 4, z value of negative 4. And of course, you could double check, triple check your answer by plugging them all in to each equation and making sure that it works. Plug in a 1 right there, that's 1. Plug in a 4 right there, that's negative 16. 1 minus 16 is negative 15. Negative 15 plus 3 times negative 4. Negative 15 minus 12, that really will give me negative 27. Plug in a 1 right there, that's 2. Plug in a 4 right there, that's 8. 2 plus 8 is 10. Plug in a negative 4 right there. Negative 3 times negative 4 is positive 12. 10 plus 12 really is 22. Plug in your z value of negative 4 right there. It will give you negative 16. We've triple checked it. We know that this is absolutely 100% correct. Again, I recommend you guys use a calculator and write down the numbers as you plug them in to see if it works. I just did them in my head because you guys are all here observing me and letting me know if I make a mistake. So that's it.